Friends, very good morning to everyone. We dealt with the mechanisms of reactions for substitution reaction. Here, as we know that substitution of alkyl halides follows either a primary order kinetics or a secondary order kinetics. To explain why few of these alkyl halides undergo substitution by following first order kinetics or some undergo by following second order kinetics. To explain that, two mechanisms have been put forward and we have seen about SN1 mechanism. In SN2 mechanism stands for substitution nucleophilic bimolecular reaction. The rate of the reaction is dependent upon the concentration of both the substrate, that is RLG, and the attacking nucleophile Z minus. In this substitution nucleophilic bimolecular mechanism, the attack of the nucleophile onto the substrate and the leaving of the leaving group occurs simultaneously in a single concerted step. Cn minus, a nucleophile, attacks on the carbon to which the halogen is attached, which is a good leaving group. The bond formation between the carbon and the nucleophile and the bond dissociation from the carbon and the leaving group, that is bromide here, occurs simultaneously. And transition state is formed in which there is a bond, half bond formed between the incoming nucleophile and the carbon, and the half bond is broken between the halogen and the carbon. The other groups move away. This is the transition state. Slowly, as and when the bond between the carbon and the incoming nucleophile becomes stronger, the carbon and the leaving group bond becomes weaker, and slowly bromide ion leaves and nucleophile comes and attacks. When we start with the molecule with S configuration, we end with the molecule with R configuration. There is total inversion of configuration. This inversion of configuration is an indication that nucleophile has attacked from the back side. If at all it would have attacked from the front side, then the configuration of the starting material would have been retained in the product also. But here there is reversal of configuration. There is a clear-cut indication that attack takes place from the backside of the leaving group. This is the first evidence given in support of the molecular mechanism put forward. Unlike the SN1 mechanism, there is no carbocation, an intermediate. Here, there is a transition state. In this transition state, half bond is broken between a carbon and the leaving group, and half bond is formed between the carbon and the incoming nucleophile. Whatever has been proposed is evidenced by this Walden inversion. It indicates that there is no carbocation formation. It in turn indicates that the bond breaking and bond making occurs simultaneously. The other evidences which were given is this polarity of the solvent. In case of SN1 substitution mechanism, we have seen that as the solvent polarity increases, rate of the reaction also increases. But in case of SN2 mechanism, it is totally reverse of that. That is, as solvent polarity decreases, the rate of reactivity increases. It in turn indicates that there is no carbocation formation. The positively charged polar solvent, it also decreases the nucleophilicity. Hence, it decreases the rate of the reaction. In the polarity, as it increases, the rate of reaction decreases means it indicates that the intermediate formed is not the carbocation. Means the attack has taken place from backside. It is an indirect evidence given in support of the mechanism proposed. The living group, as the basicity is more, the living ability will be more. Thus, the more the basicity, more the living ability, more the rate of reaction, which is similar to that of what we have seen in SN1 mechanism. As the nucleophilicity of the nucleophile increases, reactivity increases. In case of SN1 substitution, the nucleophilicity of the nucleophile did not had any effect in the reaction rate. Means that was not involved in the rate determining step. Here, the increase in nucleophilicity increases reactivity means it in turn indicates that nucleophile is involved in the rate determining step and its concentration and its strength affect the rate of the reaction. In case of SN1 substitution, we have seen that the reactivity decreases as the alkyl group goes on decreasing. Here, it is definitely reverse of that. Methyl halide is more reactive than ethyl halide, or a primary alkyl halide is more reactive than a secondary alkyl halide is more reactive than the tertiary alkyl halide. Why is it so? If there are three alkyl groups, as in case of tertiary alkyl halide, the bulkiness of the alkyl group, it hinders the incoming group, that is the nucleophile, to attack on the carbon to which the living group has attached. This indicates that the attack is taking place from the backside as proposed. If at all there is no alkyl group, instead of it there is hydrogen, the bulkiness decreases and steric hindrance also decreases, and that's why nucleophile attack chances increases. Hence, it is another evidence to say that attack takes place from backside. Stereochemistry, as we have seen already, if I start with S configuration, I end up with a compound or a product with R configuration and vice versa. As there is bond formation and bond making simultaneously occurring, there is no chance of rearrangement. In case of SN2 substitution mechanism, rearranged product is not formed. It is an indication that association with nucleophile and dissociation with living group occurs simultaneously. These are the evidences which are given in support of the mechanism proposed. It can also undergo elimination reaction that will be the subject of discussion for the coming class. Till then, have a nice day. Thank you.